Hi, I'm Kingsley Jasper, Altair Engineering India. In this session, I'll be talking to you about the RADIOSS engine file and the various guidelines that are to be followed in defining of a engine file in RADIOSS. The engine file in RADIOSS is the file name followed by an underscore and then 0001.rad. The engine file or the engine and radios consist of the various case controls. The engine and radios produces the various output files such as the output contours which we are requested and then the time history plots, and also the engine and radios can be used to restart a run. Next, let's see the various fundamental entities that are to be defined in any engine file and radios. These four basic fundamental entities are to be present in any engine file and cannot be neglected. The first fundamental entity to be present or defined in any engine file in radios is the termination time. The termination time is the event time or the event which has been considered for simulation. It is the time as to how long the event takes place. So that is very important in any run. Next comes the various contour output requests. Here we request all the various contours that we need to be present as the output. Here let's say that the various contours that we request as outputs generally are the stress, strain and displacement. These can be requested as an output in the engine file and radios. Then comes the animation frequency. In animation frequency, we specify the time interval at which the animations are to be written during a radios run. After that comes the time history frequency. The time history frequency is the time gap or the time interval at which the radios engine writes a time history plot. So the frequency at which the time history plot has to be written is specified in this time history frequency tag. Now I'll show you a sample engine file and I will tell you how these fundamental entities which I told you are defined in an engine file in radios. This is a engine file in radios. As you can see here, it's the file name followed by an underscore and then 0001.rad. So before I start explaining about the engine file, the unit system that I have followed in this session is Newton, tons, mm and seconds. As you open the engine file in radios, the first thing that you can see is the version of the engine file. Here it is in radios 14. Then the first thing or the basic fundamental entities that are to be defined in an engine file. Firstly, what comes is the termination time. The termination time is defined here in the engine file and radios. Here you can see it's the run followed by the file name, and you can see here a termination time of 0.3 seconds. So this event will get terminated at 0.3 seconds. The next fundamental entity which we saw were the various contour outputs requested. Here these are the various contour output requests that are placed for the radios run. The various output requests are which are given here are unm vect dis, which is the displacement, unm vect well, which is the velocity, unm lm EPSP, which is the element plastic strain, and then unm lm Varnum, which is the Varnum stress. The next fundamental entity which comes is the animation frequency. This is the frequency at which the animation files are to be written during a run and radios. Here you can see animation frequency time of 0.005 seconds is given. So at every 0.005 seconds animation file is written by the engine and radios. The next basic entity or the fundamental entity which comes is the time history frequency. which is given by T file. As you can see here, the time history frequency is input as 5 e raised to minus 4 seconds. So at every 5 e raised to minus 4 seconds, you can see the radio's engine writes, or the T01 file gets updated for every 5 e raised to minus 4 seconds. And the animation files and radios which we request here can be imported into Hyperview by either importing the A001 animation files or the .h3d files which we get after the completion of a run and radios. By importing this into the Hyperview, we can check for the various contours and the time history file, which is the T01 file and radios. We can import that file into hypergraph, and we can see the time history plot in hypergraph. Now I'll tell you about the various guidelines that are to be followed during the definition of a engine file in radios. I have considered the same sample file which I had showed you, and I have divided it into the various entities that I told you, and I will give you a brief guideline as to how the engine file has to be defined in radios. Firstly comes the termination time. In this case, the termination time or the event time is 0.3 seconds. Let's assume the termination time to be X. Next, which we need to define is the animation frequency. Let's assume the animation frequency to be y, and as you can see, y equals x divided by 30, that is the termination time divided by 30. We take divided by 30 as to ensure that we have at least 30 animation files. This is again done in order to make sure that we have a smooth transition during animation and there is no staggering effect in the animation. By taking 30 files, we can make sure that there is a smooth transition during the animation. But in this case, as you can see, we have taken 0.3 divided by 30 and its equal results in 0.01 seconds. But as you can see here, I have taken a animation frequency time value of 0.005 seconds. This is again done in order to have a smooth transition in animation and to not have a large time gap during animation. The basic suggested guideline is when the value x divided by 30 is greater than 5 e raised to minus 3 seconds, it is advised to still take up 5 e raised to minus 3 seconds. By this we can make sure that the animation is as smooth as possible and there is no large time gap between two animation files. The next entity which we need to define in the RADIOSS engine file is the time history frequency. Let's take the time history frequency to be Z, then Z equals Y divided by 10, which is the animation frequency time divided by 10. In this case, it is 0.005 divided by 10, which results in 0.0005 or 5 e raised to minus 4 seconds. So at every 5 e raised to minus 4 seconds, the time history plot gets updated in the engine. Now I'll give you a few suggestions as to how to define the termination time in the RADIOSS engine file and the various animation contour outputs which can be given during a run in RADIOSS. For the termination time, if the event which we are performing or simulating in radios is quasi-static, then the termination time is directly depends on the loading time. Let's say in my case, if the loading is done in a period of 0.3 seconds, then the termination time or the event time is directly equal to 0.3 seconds. That is in a quasi-static condition. Well, when we take an impact simulation, the impact simulation has to run till the internal energy and the kinetic energy balances out. This time can be taken from our previous experiences as to when the energy gets balanced, and there is no hard and fast rule as to at this time the energy always gets balanced. It's depending on the various run and the conditions which we are taking up during a run. That is how the termination time or the event time has to be decided and gave as input in the radios engine. And the various contour output requests. The basic contour output request which we can be placed for every run are the anum, elem, which are the elementary variable choices, as to EPSP, which defines the element plastic strain, and Warnum, which is the von Mises stress. Next, which we can or request as the output are the anum vect, which are the nodal vector choices, as to disp is the displacement and well is the velocity. These are the standard animation contour output requests which we can request for any run in radios, but if we have some special cases and we need some other various contour output requests, there are also various other contour outputs that are available in radios. I'll show you a few now. In order to do that, you need to go to the solver browser, right click and create engine keywords and anum elem, or the card already exists in the model, and you can go to the LM card here, and when you click you can see the various other options that are available. Here you can see the density, element plastic strain, which is already defined, and one stress is defined, and the energy, the damage along XYZ, failure, hourglass, stiffness, and so many other contours are available. And also in vect you can see there are also many other options available in addition to the defined ones, which are the displacement and velocity. You can see so many other contour outputs. In addition to these, there are also many other contour outputs which you can see in engine keywords. Anum, you can see anum cut. This is used to get a section cut during animation. And one more option is in the engine keyword is print. The command print is used to control the output print frequency. That is, in a run, if we want to see the data, let's say not in every cycle, but as to in once in every 500 cycles or say 1000 cycles, we can say the solver to print only in the once in 500 or 1000 cycles using this command. So like that, there are many other contour options which are available in radios, and we can use that to our specific reasons or the specific needs during a simulation in radios. And as far as these guidelines are considered, these are not a hard and fast rule to which we always need to stick to. These are some basic guidelines that are suggested when we have no idea as to how an engine file has to be defined in radios. When we have the experience and we know as to how these are to be defined, we can go about with our own values, and there is no compulsion as to we need to stick to these guidelines always. So those are the guidelines and the various contours and the engine file in radios. That's about in this session. Thank you.